Hello and welcome to another episode of Anything Arduino. So in the last episode we connected a 4-digit 7-segment LED display directly to the Arduino. Very similar to what we did in episode 7 with a 1-digit 7-segment LED display. So today we are going to do what we did last episode and what we did in episode 9 together. So we're going to work with a 4-digit 7-segment LED display, and we're going to connect it to the Arduino with two 595s or 74HC595, so shift registers. Using two shift registers we are going to display numbers on our 4 digits using only 3 pins on our Arduino. So let's just dive right into binary counting land and see what we can do. So there's a few different ways we can use the 595 to control the LEDs on this 4-digit segment. So if we start with this model where you have 12 pins in one capsule, so we can use a 595 to control the segments of the LEDs. So instead of 8 or 7 pins to light up all the LED segments, as we did in the previous video, we can use just 3 pins with this. And then we can still keep the 4 pins for multiplexing between the digits. So using 7 pins instead of 12, we would get all the numbers. Now, going the opposite route, and if we use 4 of these, if we have 4 of these, we could actually, using only 3 pins, we could connect one 595 to each LED. Now this would mean a lot of wiring, so you would have all 7 or 8 LEDs connected to one 595, and then you serial connect them and you send really big binary numbers through that serial port, and then you would get all 4 to light up. Now this is really good because then you don't have to have a quick loop. So if something happens in the code that makes the loop go slow, this will not get it won't start to flicker or anything like that, because once you've sent the values to the chips and you flip the latch, they will hold the numbers, whatever you give them, until the next you flip the latch and send new data. So a very chip intensive method, but very good. We are not going to do that. We're going to work with this one, and we're going to do something in between those two methods. So we're going to use the 4-digit LED display, and we're going to use 2 of these 595s. So 1 or 7 on the first one is going to be for the LED segments, and then the last one on the first 595, and then additional 3 on the second one is going to be which of the LEDs we are going to which of the digits we are going to light up. So I'm going to try to explain this a bit better by drawing a bit, and hopefully you will understand. So I have this sheet from the episode 9, I think, where we went through and how to connect a 1-segment LED display, one of these, how to connect one of these with a 595. So what we'll do now is, because here we are only using the 7 first bits, so so the last bit on the first 595 is 128. That's the value, the binary value of the last bit. And then when we change the chip, what we actually do is we just add 8 bits to the row. So the next bit after this will be 256. And this is the 1 value on the first chip. And it is 256 on the second, because 8 bits, the value of that is 255. So the first bit on the second 595 is 255 plus 1, 256. So this will make it, just trying to explain here, this will make it much easier later in the code when we're going to do the math for this. So second one, 1, 2, 3, 4, 512 and 1024. So with this, say we want to, let's see if we can have them all here. Say we want to make a 1 on the first digit. Then we will actually send 121, because it's a common A node, plus 128, so 249. By sending 249, we will put a 1 on the first digit, and so on and so forth. So just expanding on our binary counting. So binary counting 102, maybe that's the course, this course name. So let's plug it in and look at the code. So with the connection diagram we made in the last episode, when we added 2 columns for the first 595 and the second 595. You can't see it where I'm pointing there. First 595 and second 595. This is how we're going to connect it. So the Arduino pins isn't interesting anymore. What is interesting is the LED pin. So I'm just going to connect them here real quickly, just as it says on this diagram. I'll take a picture of this and link it in the description below. There. Now we have all the A, B, C, D, E, F, G pins connected. And now we are going to the digit pins. We're going to connect these. So, and we're just going to continue on the row. So we are up on bit number 6 on the 595. So digit number 1, first digit here, is number 12. So this one should be connected to pin 7. So, and that was the last bit on the first 595. So now we go over on, so digit number 2, we have to continue on number 12, number 9. So now we have to continue with the first bit on the second 595. So pin 15. And 8 to pin 1, which is the second bit, and 6 to number 2. There. So we still have quite a lot of bits left. We're only using 3 on the second 595. And that's it for that. And a few more cables, and we're going to connect the data, latch and clock pins. So now we have our 3 pins here, and we are going to use the exact same 3 pins we used in when we last worked with the 595 and LED displays. So pins 2 through 4, and pin 2 on the Arduino is going to be a latch pin. We connect that to STCP, which is pin 12 on the first 595. The second pin, or the pin 3 on Arduino, is the data pin. Connect that to pin 14. And lastly, pin 4 on the Arduino is the clock pin. We connect that to SHCP, or pin 11. Now, because we are using 2 595s, we need to control the second one as well. So first off, we are going to just connect the STCP and SHCP, so pin 12 and pin 11, yeah, 12 and 11, just connect them between. So we connect pin 11 to pin 11, and also pin 12 to pin 12. And the data pin we need to do a bit different with. So now we are going to use the data out pin on the first 595 to connect to the input pin on the second 595. So data on the second 595 is pin 14, and on the first one it is pin 9, which is data out. We of course also need some power. So 5 volts and ground. And ground is pin 8, and voltage is pin 16. And then we need to serial connect that to the second one. Pin 8 to 8 and pin 16 to 16. There. There's also 2 final connections you need to make on both chips. So we need to connect ground to pin 13 on both chips, both 595s, and also we need to connect plus 5 volts to pin 10, also on both pins. This is also described in episode 9. For the code, we're going to use the same code as we did in episode 9 when we did a 7-segment LED display with the 595 just one, simple. So we're going to get that code and just make a few alterations to make it work with 4 digits. So because I didn't save that sketch after I made the video, and a few people asked for it, so Erwin van der Meulen was kind enough to write it up and share it in the comments. So I'm actually going to take it there so I don't have to write the sketch again. Thank you, Erwin. That was nice of you. So here's the exact code as it was used in episode 9. So if, as we said before in the binary coding 102 or binary counting 102, D1 was 128, so the last bit on the first 595. D2 was 256, which was the first byte on the second 595. D3 512 and D4 1024. I hope you all see that each new bit is a duplication of the bit before. So that's how it works. So because we are using a common A node 4-digit 7-segment LED display, so we will make the 8th bit high on the first 595, and that will light up whichever digit we is trying to write on the first digit. So for example, if we want to write a 0 on the first digit, we will write 128 plus 64. So this will add the value of D1, the first digit. So we add 128 to all the numbers, and we will then get a counting from 0 to 9 on the first digit. There. And then we upload this. There was one little symbol too much there, copied from the comments section. All right. So if you ignore the other digits that is also lighting up in this sketch, you will see that the first digit is lighting up all the time. Now, because we are shifting data on two, we actually have two 595s connected, so sometimes it will light up a few of the others. I'll soon show you how or why. If we now want to do the same as we did in the last episode, we want to write a 0 on the first digit, and as 1 on the second, and 2, 3, like that. Once again, we need to do this. We need to do these 4 numbers, and we need to do them really fast. So multiplexing once again, but we are multiplexing with the shift out, with the serial data. So the 0 is nothing special, but we need to add one more command, because now we are going to go up and go over the 8 bits of the first 595. So we actually need to add one more row to not have all the other bits jumping around as they do now. So we need to add another shift out. And everything is actually the same. But here we add this, what do you call this command? Unfortunately, I don't know what it is called. I'll write it in the post-production. So we add. And we need to add this to, once again, to all the numbers, to not get any stray bits lighting up other digits. So we upload this as well, so you see the difference. Now only the first digit is changing. And this is because, once again, that because we are shifting data, so when we add new 8 bits to the first 595, it pushes the other bits out to the other 595. That is why we need to shift out twice to empty the second 595. Right. So we write a 0 to the first digit. And we have 1 millisecond there and 1 millisecond there. Just fixing these 3 bytes. And then we will not care for the rest of these numbers. 128 for the first digit. 256 for the other digit. I really hope you understand why I write 256 now. So this is the first bit on the second 595, which we have connected to the common A node of the second digit. 512. Oops, sorry about that. And 1024. Now, we upload this, and this should write 0123 on our 4-segment LED display, which it so eloquently does. So, that's it. Now you know how to use a 4-digit 7-segment LED display with 2 595s and get that to work. Alright, so here we have it. It is just displaying 0, 1, 2, 3, and it is connected with 3 pins, and we have a lot of wires connected to our 2 595s. So this is how easy it is to work with 595s and 4-digit 7-segment LED displays. As I said, we are only using 3 bits on the second 595, so having the same code and just adding those extra bits by, we ended at 1024, so adding 2048, 4096, and then I can't count any longer, up to 16 bits, so we can actually add another 5 digits, which, well, another 4-digit LED display, no problem. So, and still only using 3 pins on our Arduino. So if you're short on pins on your Arduino and want to use 7-segment LED displays, this is a great way to do it. So I hope you learned something today, and if you have any questions or suggestions, you know to leave them in the comments below. If you haven't already, please subscribe, and of course like this video, it was great. As I've said before, I am moving, so I'm unsure if I will get any more of the Anything Arduino videos out before that, so that will be in a month or 2. So I need to start packing my workshop down and stuff like that. So, but I have more stuff that I need to just finish the post-production of and see if I can stay off camera for that long. Until then, I will see you again, I hope, after I've moved in my new, improved workshop, hopefully. So until then, take care, bye. That went well.